All right, no, we had a little trouble. Everybody had some trouble in this assignment. There are two things that can lead to trouble. One is you gotta be able to factor these things. So if you're having trouble with factoring, everybody's doing the right thing, but you want to get a little bit quicker at it. So you probably need to practice a little more with it. Go back and review some of the assignments, do an alternative assignment, whatever. But everybody understands, and everybody understands the distributed law, understand how the factoring works. And some of you are pretty quick at it. Some of you in between. So anyhow, we're gonna find the least common multiple. Now, the least common multiple, that's what the assignment was on last time, okay? So how do we find the least common multiple? Well, I went ahead and factored these. Now, some of you had them factored, some didn't, but I wanted to make sure everybody saw how you work this out. We want the least common multiple of this and this. To get the least common multiple, it's got to be factored. So we factor. Now we find the least common multiple, and the least common multiple has to contain this, has to contain this, has to contain this, has to contain this. Okay? As factors. Now, before I go on with this, let's get the idea with numbers. Okay? Let's say you've got 24 and 18. What's the least common multiple of 24 and 18? Well, 24 is divided by 2. You get, now I'm going to actually do this. Okay, 24 is 2 times 12. 12 is 2 times 4. 4 is 2 times 2. And yeah, you're right. It's 4. It's 4 times 3. Numbers down. Not necessarily any thing resembling the thought intervening, and I don't see my planning stuff. Oh, there it is. Okay. Now what I was doing, I had to clean the practice physics back. Okay. Start over. Write this correctly. Okay. 24 is 2 times 12. 12 is 2 times 6. We've done something to make any sense. 6 is 2 times 3. And nothing else breaks down. Okay. In other words, 12 gives you 2 times 6, 6 gives you 2 times 2. 18 is 2 times 9, and 9 is 3 times 3. Understand that process? And that's something you should have seen many years ago. And I think, I've got to make sure it's there in the assignments. Anyhow, simple process. Just keep dividing by the smallest number you can until you're done. Okay, good suggestion. Not quite, but okay. How many 2s are we going to need? Just show me with your fingers. To contain this number and also to contain this number, how many 2s are we going to need? Okay, some people are not sure. 4, 3. We need 3. If we got 3 2s, then we got this one, and we got these 3, right? We got them both covered. Okay. What we need is whatever number has the greatest number of 2s, that's how many 2s we're going to have. Okay. So the greatest number of 2s is 3. If you got 3 2s, then we certainly got 1, right? We don't need 4, just need 3. And then we need 2 3s. We've got to have 3 and 3. If we multiply this out, that's 8 times 9. That's 72. 72 is 3 times 24. It's also 4 times 18. We say 72 is a common multiple of 24 and 18. Okay. It's also the least common multiple. It's got the least number of 2s that you can have in order to contain 24, because you got to have 3 2s to contain the 24, right? And it's got the least possible number of 3s, which would be 2 of them, because you need enough 3s to hold the 18. So you kind of see it this way. Okay, let 24 be your purple number. Okay, we've got 24. Right there's 24, right? And got 18. Well, we've got 2 times 2, 2 times 3 times 3. So right here is 24 in purple. Right here is 18 in yellow. So this number is 72, and it contains 24, and it contains 18. Not only that, but I know if this number is 3 times 24, because there's 24 times 3. And I know that it's 18 times 4, if I didn't know that already, because right there is 18, and there's 2 times 2 is 4. So that's 4 times 18, or 24 times 3. Now, you maybe want to review least common multiple of numbers if you aren't aware of it, okay? That goes back to basic arithmetic and basic arithmetic with fractions. And I think, I'm not sure that the assignment we started with in fractions really covered this. Probably should have. Maybe I need to put that into the assignment. Anyhow, so if I wanted to add 7 24ths and 11 18ths, I take my 7 over 24, multiply it by 3 over 3, because that would give me a denominator of 72. And then I take the 18 and I multiply it by 4 over 4. I'm going to go ahead and do that. Just illustrate the entire process and why this is important. So I know the least common multiple is 72. And I know that you get 72 and multiply 24 by 3. So 24 times 3 is going to give me my denominator 72. And of course, I've got to multiply by 3 over 3, and I've got to multiply by 1. If I don't multiply by 1, I change my number. Okay. That's 11 over 18 times 4 over 4. That 18 come out somewhere else. Bad looking 8, maybe. Tell what it is. Okay. So having found my least common multiple, I can do this. 21 and 44 is 65. And the only number 72 has in it are 2s and 3s. Okay. There are no 2s or 3s in 65. 65 is an odd number, so you can't divide it by 2. You divide 60 by 3 with 5 left over, and 3 doesn't go into 5, so 65 isn't divisible by 3. You could do a prime factorization. 65 is 5 times 13, as you find if you divide it by the smallest possible number. It won't divide by 1. I mean, it won't divide by 2, won't divide by 3, won't divide by 4, but it does divide by 5. It ends in 5, there's a hint. Okay, and you get 5 times 13, and nothing divides 5 and nothing divides 13. They're both prime numbers. Okay, so you really want to understand this example. Go back to the video, whatever it takes. Look up least common multiple, adding fractions. Okay. Now, we want to find a least common multiple here. So, give you a hint. Let's see. LCM got to contain each factor. Okay. So that means it's certainly got to contain both of these factors, x minus 3 and x plus 2. Okay. What else does it have to contain? What are we missing? See if you can answer. See if you can write that down. Okay, we're having a little trouble. See what's going on here. Okay. Let's look at this. Let's say you just take one of these, doesn't matter which one. I wrote this one down. Okay. We got to have everything here. We got to at least have this. Okay. Now, we also have to have all this. Okay. So we've got x minus 3. We got x plus 2. So we got this. We got this. We got any of this? Oh yeah, we got the x minus 3. Okay. So x minus 3 is contained in this. So this x minus 3 is contained here, and this x minus 3 is contained. We don't have to write it down twice. It's got to be there. Okay. So what are we missing? Well, it ought to be pretty obvious, right? Tell you what. I'm gonna close my eyes. Here's the chalk. Tell me what it'll move it up, down, right, left, or out there or in there, but I can't go through the blackboard. So better just go up, down, right, left. Okay. Somebody tells me to go into the blackboard. I ain't that tough. Okay. Okay, so which way am I going to go now? Up, up, keep pointing. I'm seeing some ups. Yeah, okay, now we're switching to over, up, over. Some people want to go up, some people want to go over. Some people want to go up, over, 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 over. Tell me when to stop. You know. Okay, keep moving. Stop. There it is. Okay. Maybe I should have moved a little faster. Could have said, you know. So we need the x minus 2. It's got to go down here. Okay. Now we're going to see what good that is when we try to add these things, because we don't need to do what everybody's wanting to do. we can do something simpler. Okay? Just like down here. I could have done 7/24 plus 11/18 a little bit differently. Let's see. I think I could have said my common denominator is 24 times 18, couldn't I? I could have done this. That wouldn't have been wrong. Would have been unnecessarily burdensome. Multiply it. I think 24 times 18 is 432. Okay. Let's see, it ought to be 20 times 18 is 360. Yeah, be 432. It's calculated in two ways. You got the same thing. Okay. And everybody knows 7 times 18 is 126, 11 times 24 is 264, right? So I could have added that up and had it all over 432, and then I tried to reduce that, right? When I did this, I didn't even have to reduce anything. It could have been that I'd have to reduce something. In this case, I didn't. Okay, which is easier, this or this? Yeah. So finding the least common multiple gives us our least common denominator. Okay, the least common denominator can be a little hard to find. 44 and 18. Some of you have good arithmetic. Some of you have okay arithmetic. If you got real good arithmetic, you can look at those numbers and figure it out. If the numbers are a little more complicated than 24 and 18, you're going to have trouble. And you're going to have trouble. But if you do a prime factorization, you can always do this, okay? Over here, it's similar. If I try to add these two numbers, yeah, okay, I can multiply both the numerator and denominator here by x minus 3 times x plus 2, and multiply the numerator and denominator here by x squared minus 5x plus 6. Now we have to do a lot of distributive law. Take a big chance of making a mistake. Whereas if I know what the least common multiple is, it's much simpler. So that's why we find the least common multiple. I don't want to spend too much time on this, but it's something you really need to work on. Okay. You can always multiply by, multiply the numerator and denominator of this by this, and the numerator and denominator of this by this denominator. Okay. Save yourself a lot of work if you know how to find the least common multiple. It's not that difficult once you get things fast. So what I want to see if you can do now, see if you can find the least common multiple of these. Okay, I really do recommend that you follow the steps the way I'm writing them out, because if you're a little bit confused and scatter things a little bit, or don't write them out in a form that really tells you what's going on, you're more likely to make a mistake. Okay. Try to keep things in a form that you see here, or if you have a form, if Open Math shows you a form that you prefer, you don't have to use my form, but use a consistent form when you're first doing these. Don't be shortcutting it and scattering things around when you're first doing it, because that makes it harder. Okay, so we have this. And this. Now, so far, I'm following the same pattern that I did here, right? So if you follow my pattern, you'll see that we're going to factor this, and we're going to factor this. Then what do we do? Well, I'm going to tell you because we need to move on, but then we write down one of these. Doesn't matter which one. This has to be part of it, and this has to be part of it. So we can just write down either one. So we're gonna write down x minus 3 times x minus 1. Now we look over here. We've already got x minus 3. So this will give us this. And then we're going to need, we've got this. So I just kind of put a check mark on this, that one we've got. But this one, we don't got, so we're going to put it in there. There it is. Now that's going to make it much easier. Do these calculations. I'm going to go ahead and do the first one. And then I'm going to ask you to do the second one. Okay. The first one. I use an equal sign here. And I'm going to write down something that's equal to this. Okay, I could write it down underneath. I could do the equals and then underneath, same thing. Okay. But since I don't have a lot of board space, I'm going to do step down here. And then I'll continue down here. Okay, so this equals this. In other words, when I say we've got to factor these things before we can do anything. So this is fairly easy to factor. So right there are the factors. Okay. Now we need a common denominator. What's our common denominator? Well, it could be this times this times this times this. You multiply both denominators. You get a perfectly good common denominator. But you don't want to kill yourself with multiplying out a bunch of distributive law stuff. So you use the least common denominator. Okay. So we identify that the least common multiple of these two denominators is just what we found here. And that's our least common denominator. So I'm going to just make myself a note here. Least common denominator then is x minus 3 times x minus 1 times x minus 2. That's what we found over here. It's a little crowded, so this kind of boxed off. This is not part of this. So we write off to the side. I've had more room. You know, I write it over here. And then I would say, okay, so this equals x plus 1 over x minus 2 times x minus 3. And then I'm going to multiply by something over something. So I get the least common denominator. And then it's going to be plus x minus 2 over x minus 3 times x plus 2 times something over something. So what do I have to put here in order to get this denominator? And what do I have to put here in order to get this denominator? Can you write this step out and fill in the blanks? Okay. I think we still have a little trouble here. Okay, you want this denominator. You've got this denominator here. What is it that you don't have that's over here? It's the x minus 1, isn't it? Okay, because you got the x minus 2, right there it is, and you got the x minus 3, there it is. You need x minus 1, just like over here. To get the common denominator of 72, you had to multiply 24 by 3, right? 3 was missing. You had to multiply the 18 by 4. The 4 was what was missing. Go back to this. Okay, so we have now. If I multiply this by x minus 1, then I've got it. I've got x minus 2. I've got my x minus 1. And I've got my x minus 3. Okay, so what do I have to do over here? Write that out. Okay, I really apologize because I caught this out of my eye or something like that. And I did, I wrote down the least common denominator of this and this. Okay, when I'm doing this and this. So, big apology, but least common denominator. Here, we have the x minus 3 and the x minus 2 and x minus 3. We don't have an x plus 1 in any of this, do we? Okay, well, I wrote down x plus 1 and use this common denominator, which applies to this problem and not this because I just wrote it down without that. Okay, so big boo-boo on my part. Might be a little confusing. I really apologize for that, but let's correct it. Okay. First of all, tell me what's my least common denominator for this and this. Write that one down and circle it. Okay, so now correcting what I did when I used this denominator for this problem doesn't apply, but it is going to apply to this one. I'm going to ask you to do this one in a minute. Okay. But what we have here now, what's our common denominator? Well, people pretty much got that. You write this one down, x minus 2 times x minus 3. And then you see what's missing out of this. Okay. What's here that's missing from here? It's the x plus 2, right? So now we've got everything. We've got x minus 3, x plus 2, and x minus 2. What do we have? We can check it off. We can say, okay, we've got the x minus 2. Right there it is. And we got the x minus 3. Right there it is. We don't have the x plus, well, and then over here, what have we got? We want to have x minus 3. Do we have it? Well, yeah, we got it. So this one gets 2 check marks. Doesn't mean we've got to have it there twice. We're just going to have it there. And then x plus 2. We need x plus 2. We have x plus 2, not until we write down x plus 2, right? So now we can see that both of these factors occur in the denominator, in this least common denominator, and both of these factors occur here. Okay. So what I'd like you to do is now complete this step. Show me what you get. Okay. So what we have here is we're going to get this denominator. So we don't have, we have the x minus 2 and we have the x minus 3. We don't have the x plus 2. We need that x plus 2. So I have to have an x plus 2 here. We can't have an x plus 2 here. We can't just put it there. Because if we multiply this out, we have the same fraction we got up here, but with a different denominator, right? It's not the same anymore. But if we put an x plus 2 here, then we're really just multiplying by 1. Okay. And we haven't changed the value of the fraction. Over here, we multiply by what's missing. Here's our denominator that we want. We've got the x minus 3. We've got the x plus 2. We're missing the x minus 2. So put the x minus 2 there. And there we got it. Okay. Now there's more. We can multiply these things out. We come over here and all the way up here. And let's write out what we've got again. That x plus 1 over x minus 2 times x minus 3 times x plus 2 over x plus 2. I'm going to put parentheses around these because we're going to end up multiplying them. And then we have plus and by the way, x minus 2 over x minus 3 times x plus 2 multiplied by x minus 2 over x minus 2. Okay, being careful. I think that's what we got down here. Okay. Then we multiply our numerators. Well, we multiply out x plus 1 times x plus 2 over. Well, actually, now we've got the same denominator. If we multiply, well, I better do it. Okay, we got x minus 2 times x minus 3 times x plus 2. And we just multiply the numerators and we multiply the denominators. And then we've got plus x minus 2 times x minus 3 over x minus 3 times x plus 2 times x minus 2. Same denominator. The factors are in different order here, but they're all the same. Okay, there's our x minus 3, there's our x plus 2, there's our x minus 2, and that's all we've got. So now we can write this as x plus 1 times x plus 2 plus x minus 2 times x minus 2 over x minus 2 times x minus 3 times x plus 2. Now the rest is simple enough. We can multiply these using distributive law. We're going to get x squared plus 3x plus 6 plus x squared minus 4x plus 2 divided by x minus 2 times x minus 3 times x plus 2. We don't multiply the denominator out until we simplify the numerator and see if it factors. It might well be that if the numerator factors, you'll have a factor up here that matches one of these. I don't know if that's going to turn out to be the case or not. Probably not. We've got 2x squared here minus x plus 8 over x minus 2 times x minus 3 times x plus 2. Can't factor this. 2 and the 8 are too big. I'm not going to get it minus 1 out of that. Of course, I can cheat and use a quadratic formula and tell right away. But you'll see how to do that. Okay, so there we have it. Now you can do exactly the same steps with this. When I planned on doing this, we're already 2 minutes over time. And not surprisingly, we're having some trouble. I'm going to extend some of the assignments. Probably some stuff would be good to do at the end of the semester, but it's not totally required. So probably going to have to leave some of that out so we can spend the extra day on this whole mess. Okay. First place, try to improve your factoring. Okay. Some are pretty good at it, and some of you, still need a little more practice. And I'm gonna try to get you some practice problems in fact. Some of you probably don't need it. It's probably good for your soul anyway. Okay. And a couple of other things that I see from the major quiz. Okay. A couple of problems people are having. And we'll try to address those on Wednesday. Right now, we want to focus on this. I want to focus on that. So I'm going to try to get some extra practice problems because I think mainly people need to work more problems. You work the open math, but you've got the videos in front of you, and it's real easy to think you understand it when you don't. And we want to try to get over that. We do want to get the algebra skills up. Now, the one thing I'll say is this is one of the hardest things in intermediate algebra. Okay, which is why I don't mind spending at least an extra day on it. If we can accomplish this, that's pretty good. The more that we have to do, it's kind of a hump, and even once you're over this hump, you can't say things always get easy, but a lot of things do get easy once you got this. So really kind of focus on this and let me know if you're having problems with it, okay?